Hey guys, so today we're going to be taking the derivatives of trig functions. This section isn't very hard. If you compare it to the product rule or the quotient rule, the section is fairly easy. You'll be using, the derivatives of trig functions alongside the product rule and the quotient rule. And so it's very important you get this section. And a lot of people, they try to memorize the derivatives of the trig functions. And you can do that a bit, but it's better if you know the logic and the derivation behind the trig functions, because on a trig test or a quiz, you might forget. And but if you know the logic behind the derivation, you can quickly derive it, and then just it'll just you'll get your answer. And it's basically a bulletproof way of just making sure your answer is just right. So let's get into it. Well, we're going to start with sine and cosine, and this is a pretty natural place to start. A lot of textbooks will start here, and we just start learning trig here in general. So we're going to start learning the derivative of our trig functions from here as well. And we're going to start with y equals sine x. And we're going to use the limit definition of the derivative. So y prime is equal to the limit as h approaches 0. And I'm just going to substitute the function in. So sine of x plus h, we know our limit definition of the derivative, minus sine x all over h. And this turns, well, we're kind of stuck here, and because of this. And this is a good place to point out that trig functions, they get used a lot. And so in order to simplify some expressions, you really need to be comfortable with your trig identities. Trig identities are very, very, very important, and you're going to be using them a lot. The one we're going to use here isn't used a lot, but I will point out the ones that you will see so much, and you just need to know. You don't see the one I'm going to write down right now much, but it's important here. So what is it? Well, it is sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. And here a could be x and b could be h. Doesn't matter. So what do we get? Well, simplifying this, we get limit as h approaches 0 of sine x times cosine h plus cosine x sine of h. And this is not the hyperbolic sine or anything. This is just cosine minus sine x all over h. There we go. And this expression, this expression simplifies down to, I'm just going to erase all this, and I'm just going to write what it simplifies down to. Well, this expression just turns out to be sine x times cosine h minus 1 all over h plus cosine x sine h over h. If you just do some simplification, it turns out to be this. And, well, what do we notice? Well, here, as h approaches 0, cosine of 0 is 1, 1 minus 1 is 0, so this whole term just is 0, because this turns out to be 0. We've seen this so much in the limit section, you've probably seen this, sine x over x. Well, the limit of this is just 1, so what are we left with? Well, we're just left with cosine x. So our derivative of sine x is cosine x. Surprise. I'm just going to erase all this. That's pretty convenient. I won't lie that, the derivative of sine x is cosine x. And you can graph this and see why. So Now, what about the derivative of cosine x? Well, if you know, go through the whole limit definition of the derivative, well, you end up getting, well, the derivative of cosine x, so in this case, y double prime, because we have sine x here. Well, the derivative of cosine x is negative sine x. So I'm just going to erase all of this, actually, and I'm going to show you guys something. So I'm going to say f of x is equal to sine x. And so what's the derivative of sine x? So what's f prime of x? Well, it is cosine x. And what is g of x? Well, we're going to say g of x is cosine x. Well, what's g prime of x? Well, g prime of x is equal to negative sine x. So I'm just going to lay it down for you guys right here. Take a look at it. You know, not very hard. Pretty convenient. It's just this negative sign right here. Otherwise, it could have been a nice loop. However, we actually do have a nice loop because let's take the second derivative of f of x. So what's f double prime of x? Well, f double prime of x is, well, what's the derivative of cosine x? Is negative sine x. Now let's take the third derivative. But what's the derivative of sine x? Well, sine x, we have the negative sign up front. What's the derivative of sine x? Well, it's cosine x. Let's take the fourth derivative. Well, what do we get? Taking the derivative of cosine x, well, we got the negative sign out front. Well, cosine x, the derivative, is negative sine x. So the negative signs, they cancel out, and we're just left with sine x. So we're just going to keep going in this loop over and over again. We're just going to keep going in this loop over and over again. You know, you keep taking the derivative, you end up in this loop. And, you know, same thing here because, well, g of x is just starting there. It's just f prime of x. So, know the derivatives. The loop was just a, additional thing I wanted to show you guys because you just end up, going back and forth through that. And so let's move on to another one. Well, tan of x. So we got y equals tan of x. And we want to find the derivative. Well, we could use the limit definition of the derivative. But, I don't know, that's a little tedious, as we've seen. Using the limit definition of the derivative is usually quite tedious. So, well, what do we do? Well, what we can do is, well, like I said, you need to be really, really comfortable with your trig identities. And I know trig identities was one of those things in pre-calc that students just hated. I myself was never a big fan of trig identities when I was in pre-calc. However, you need to know them. They're really, really important, and you'll be using them a lot. And the one I'm going to show you right now, you're going to be using so much, and you need to know it like the back of your hand. And it's one of the simpler ones, actually. And that is, what else is tan of x equal to? Well, tan of x is sine x divided by cosine x. That's the identity. Well, if I want to take the derivative now, notice, what do I have here? I have a function divided by a function. And in order to take the derivative, what must I do? I must use the quotient rule. The quotient rule. And so, I got y prime, and I know my parameterization. I'm going to say sine x is just f of x is equal to u, and I'm just going to say cosine of x is g of x is equal to v. So, I just parameterized them, saying u and v. So I just assigned a letter to each of the functions. So, well, the quotient rule says u prime v, so the derivative of the numerator, I'm gonna say it as I write it. The derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. And what does this come out to? Well, y prime, I'll just write it up here in case I need space. So what is the derivative of the numerator? Well, we found it on the first slide. What's the derivative? The derivative of sine x? Well, the derivative of sine x is cosine x times the denominator, which is also cosine x, minus, what is the derivative of the denominator? Well, the derivative of the denominator is negative sine x, but these negative signs, this minus sign and the negative, they cancel out. So I just get sine x. What's the derivative of the, not the derivative, but what is the numerator now? Well, the numerator is also sine x. And this is all over the denominator, which is cosine x squared. We need to use another trig identity because we're not done yet. This numerator, there's a trig identity for it. And it's probably the most important trig identity and you'll be using in calculus because you're going to be using it so much. So y prime is cosine squared x plus sine squared x all over cosine squared x. Well, our trig identity says this is 1. The numerator is just 1. So we got 1 over cos squared x. We're still not done. We need to use another trig identity. What is 1 over cosine x? Just cosine x. 1 over cosine x is secant x. So we have 1 over cosine squared of x. So that is secant squared x. There we go. We used 3 trig identities. You need to know these trig identities because they're going to come up not just here, but in other places in calculus, not just in differential calculus. You're going to be seeing, you're going to be using them a lot more in integral calculus and, Calc 3 and Calc 4. So you need to get really, really comfortable with this stuff because it's going to come up a lot. And trig identities, just like I said, despised by students, but really important. So we just found, our basic trig functions. We just found their derivatives. Well, what did we end off here with? Well, we ended off with secant x, right? Well, what about its derivative? It's a reciprocal trig function, right? What about their derivatives? Now, what are the reciprocal trig functions? Well, we just saw one, secant x. There's cosecant x, and there's cotangent x. Those are our reciprocal trig functions. And, well, how do we take their derivatives? Well, again, these reciprocal trig functions, just in their name, reciprocal. So what did we see? Well, we saw secant x was 1 over cosine x. What's cosecant x? Well, cosecant x, knowing your identities, is 1 over sine x. What's cotangent x? Well, it's just 1 over tan x. I'm going to show you guys this one and this one. I'll derive these ones. Pretty similar steps. You can leave this one as an exercise. So let's do this. Let's start with cosecant x. I'll find the derivative of that. So y is equal to cosecant x. And, using our trig identities, what can we rewrite this as? Well, we can rewrite this as 1 over sine x. So notice one thing. We're just going to keep playing with sine x and cos x, sine x and cos x, rewriting all of the other trig functions in terms of sine x and cos x. In terms of sine and cosine, we're just going to keep doing that over and over and over again because all of these depend on sine and cosine. So we just rewrite them in terms of sine and cosine. So that's basically your first step. You want to rewrite other trig functions in terms of sine and cosine in order to take their derivatives. So we wrote this in terms of sine because, cosecant is just 1 over sine x. So let's take the derivative. Well, how do we take the derivative? Well, we have a function divided by a function. A constant function, 1, divided by a trig function, sine x. So let's use the quotient rule. It's really easy. If you say the numerator is u, you say this is v, you got u prime v minus v prime u all over v squared. Well, what's the numerator's derivative? The derivative of the numerator is, well, what's the derivative of a constant function? It is 0. So this whole term is just 0. So I'm not even going to write the denominator times the denominator. I'm just going to go to the next term. Well, what's the derivative of the denominator? Well, we found the derivative of sine x, and that is cosine x, times the numerator, which is just 1, all over the denominator squared. Well, what am I left with? Well, I'm left with this. We're not done yet. We're not done. And I'm going to show you guys now. So we have to finish this. We got to simplify it. So, well, we can recognize, again, your trig functions come into a lot of play here. I mean, your trig identities come into a lot of play. And that is, well, we can split this up into 2. Product of 2. And, well, what's cosine x divided by sine x? Well, that is just cotangent x. And what is 1 over sine x? Well, 1 over sine x is what we started with. Cosecant x. What are we left with? Well, we just got cotangent x times cosecant x. Our initial function is also in the derivative. So there we go. We're done. That's the derivative of cosecant x. And like I said, you really, really, really got to know your identities. So let's go on to the next one. Well, y is equal to cotangent of x. Well, what is cotangent of x? Well, cotangent of x is just cosine x divided by sine x. And what's that? Well, we take the derivative. What do? We got a function divided by a function. Again, we use the quotient rule. And every time you're going to be deriving these, you're going to be using the quotient rule. So let's do that. Y prime is equal to u prime v minus v prime u all over v squared. And we're going to say this is u, and this is v. This is u, this is v. So what's the derivative of the numerator? What is the numerator? Well, we need to find the derivative of cosine x, and cosine x derivative is negative sine x, times the denominator. The denominator is sine x, minus, what is the derivative of the denominator? Well, the derivative of the denominator, which is in itself sine x, is cosine x. And what is the numerator? So we got to times it by the numerator, multiply by the numerator, and that is just cosine x. And this is all over sine squared x. Okay, so we're not done yet. We got to simplify. Well, we can pull this negative sign out. So let's do that. Negative sine squared x plus cosine squared x sine squared x. Now, let me tell you, you're going to appreciate seeing this more often. And, well, why? Because it just collapses down to 1. Negative 1 over sine squared of x. Well, we're not done yet. We got to use another trig identity. And what is that identity? Well, we got to use the identity and realize that this turns out to be, oh crap, I don't have enough room. Just goes this down real quick. So negative 1 over sine squared of x. Well, this just turns out to be this. It just turns out to be negative cosecant squared x. There we go, we're done. And, as you've seen, we got so many functions here. Just so many. And memorizing this stuff can be kind of confusing. It can be hard. And as I said, you need to be comfortable, and it's very, very, very good if you just learn how to derive, different trig function, and, really know, what was it, your trig identities, because they come in so much use. And just for you guys, I'm gonna, summarize all our derivatives. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tan x was secant squared x. The derivative. I say that, knowing the logic is very important, because, let's say you just, let's say you're in university, and this is just, we didn't cover this one right here. Like I was saying, let's say you're in university, let's say you get, you do your Calc 1 class, and, oh, I never even wrote the function. Let's say you do your Calc 1 class, and, why do I keep writing x? There we go. And forgot a negative sign. Oh, guys, I don't know what's happening. Negative cosecant x, cotangent x. Okay, and I'll just explain what I was going to say after I write these down. So it's not distracted. Secant x is equal to secant x times tangent of x, and the derivative of cotangent x is equal to negative cosecant squared x. Like I was saying, it's very important to know the derivations, because when you get into, let's say you do Calc 1 in your first semester of college, but then you never get into your Calc 2 class, maybe it's full or whatever, and then you have to do it in semester of next year, you sometimes have to take your derivatives even in integral calculus, and if you don't know your derivatives, you don't remember, let's say, like, your specific derivative, you don't remember what the derivative of cotangent x, but you know your quotient rule still, and you know that cotangent x is just cosine x over sine x, then you can quickly just derive it and just, not have to go back and try to rememorize all of these. So let's do an example, and that example is y is equal to sine x times cosine x. And so what do we need to do here? Well, we need to use the product rule. So I'm just going to call this u, I'm going to call this v, and I'm just going to say the product rule is uv plus v prime u. Well, what is the derivative of sine x? Well, derivative of sine x is cosine x, as we found, times cosine x plus, well, what is the derivative of cosine x? Well, that is just negative sine x. I'm just going to actually erase this and just do minus right away. Minus sine x times sine x. So what are we left with? Well, we're left with cosine squared x minus sine squared of, well, sine squared of x. There we go, done. We don't have to simplify this. You can by using an identity. Not off top of my head, I think this is, cosine 2x, but I'm not sure, so don't take my word for that. So let's go on to a word of warning. Well, in this video, what we did was we found the derivative of sine, cosine, tangent, cosecant, secant, and cotangent. What we did not do was find the derivative of this, or, we didn't deal with our inverse trig functions. We only dealt with our trig functions and our reciprocal trig functions. So we didn't deal with these ones. I want you guys to be aware of that. You know, a lot of people, they get confused. Are these our are inverse trig functions, or are these our inverse trig functions? Well, these are inverse trig functions. These are reciprocal trig functions. Because, you know, this is 1 over, this is like 1 over cosine. It's a reciprocal of cosine. You know, so do not confuse these. To take the derivative of our inverse trig functions, we need to do something else, and I'll show you that in a different video because it requires a little more knowledge and implicit differentiation. So